graphing tangent of x isn't a lot different than graphing sine and cosine of x. The one thing we have to remember is that this graph will have no amplitude. As you can see, tangent of x will go up and down in both directions forever. Okay, so even though you may have a 5 tangent x or 20 tangent x, or maybe even negative 1/2 tangent of x, that isn't going to be its amplitude. Now that's going to have a stretch or a compression just like any other graph would, but we don't call it the amplitude. So let's talk about the properties of tangent of x. First of all, we can see right here that tangent goes through 0, it goes through pi, and it goes through 2 pi. If you go to the other side, we see it just goes through the negatives of the same thing. So tangent has an x-intercept of all the whole numbered pi's. So 0, 1, 2, -1, -2, all those pi's, tangent will have, it will go through the x-axis at those points. Now let's talk about period. Period for tangent is a little different. Okay, the period for tangent in this case, okay, our formula is going to be simply pi divided by, let's get me a pi, it's pi divided by k. Okay, it's different from sine and cosine because otherwise we would have 2 pi over k. Instead here we have simply pi over k because you can look at it. There's an asymptote. It's not drawn in, but there is an asymptote at negative pi and positive pi. Dang it, I just said they go see all the whole pi's down. Tangent, if you look at tangent's period, okay, it's pi over k. And so what you can look at here, you can look down and you can see that right in between where we have one period to the next, you can see that this is pi over 2, or negative pi over 2 in this case, and positive pi over 2. So the distance between that is exactly pi. We can look here, this would be pi over 2, then go all the way down here, that would be 3 pi over 2, still pi units long. And if we go ahead and we were to change tangent of x to, say, tangent of 4x, then my period would change to pi over 4. Okay, whatever I want to do. Tangent also has not necessarily a midline, but you can see where it has a point of inflection where it kind of turns directions, and that's what we would associate with a midline on sine and cosine. Okay, if we were to have a vertical shift, that's exactly what that point would do. That point would move up or down that exact vertical shift. And so we have period, which is pi over k, vertical shift, which would simply be up or down that exact value. Okay, now as far as the phase shift goes, that works exactly like sine and cosine. Okay, let's look at a different graph. This is going to be tangent of x over 2 plus 2. And so in this case, we have a change in our period and a change in our vertical shift. So as you can see, if we look at, we're just going to focus on this one central period of tangent, we can see that the vertical shift has been straight up 2 units. And originally we had asymptotes at pi over 2 and negative pi over 2. Well, in this case, it looks like our asymptotes are actually at pi. Let's double check to see what our period is. Okay, if we were to write this out and we're to find period would be equal to, remember it in tangent, it's pi over k. Well, if we work that out, that's 1/2, okay, or pi over 1/2. Okay, and when we keep change flip, pi divided by 1/2, that would simply be pi times 2, or it would be equal to 2 pi. Now, does that make sense for our period? Let's look at it. Okay, if we had, this would be pi units here and pi units here. So the distance from this point, or this asymptote, where you can see it goes down here, over to this asymptote. Now you can't see it. Let me just kind of pull it out some. You can see, okay, 3 is right here, and you can see where these asymptotes would fall, and they fall at pi. Okay, and you can see that now my period is 2 pi instead of pi. So you can see the tangent has been stretched out just a little bit. Okay, now how would we graph this by hand? Okay, so we're going to look now at how to graph tangent of x over 2 plus 2x. Now, I've already got the graph set up. Okay, we've labeled our intervals of pi over 2, pi, 3 pi over 2, and 2 pi, and so forth. Okay, now period is one thing that we have to calculate first. Remember, for tangent, period is pi over k, so pi divided by 1/2 is 2 pi. Alright, there is no phase shift in this case, so simply I'm going to shift my graph up 2 units. So originally I had a point at 0, that's where I crossed the x-axis, but now if I go up 2 units, now that graph is going to cross here. Okay, I do have a period change, and so I know that I'm going to have to recalculate the ends of my period. If you go back and look at this, the end of our periods were really divided off into or divided off by our asymptotes. So we're going to recalculate those asymptotes. When we go over here, if we scroll down a little bit, remember how we found the beginning and ending of the sine and cosine graphs that we had when we had a period change? This is the same way we're going to do it, except this case, sine or tangent, our tangent graph, remember, started and stopped at negative pi over 2 and positive pi over 2. So we set the inside part of x over 2 equal to our original endpoints of our period for tangent. So it'd be negative pi over 2 and positive pi over 2. Now this is something you have to figure out. That's always what you do. So the beginning will be equal to negative pi over 2, and the ending will always be equal to pi over 2. Now we look at it. Our x is negative pi. Our endpoint is x equals positive pi. And that makes sense. I look back at my period. Is the distance from negative pi to positive pi 2 pi? Yes, it is. So let's go back in and let's draw our asymptotes. Okay, so if we draw an asymptote here at pi and one at negative pi, I'll have an asymptote. Okay, I could also keep going, drawing them out further if I really needed to. I'll just have to calculate. I'll go out another 2 pi, so this would be another asymptote here out at 3 pi, and then one at negative 3 pi if I wanted to do more than one period. Okay, so now we'll go ahead and I'll draw our, in the center of that, we have what we would consider our points of inflections. Okay, now tangent, now this is something you have to simply learn. Tangent goes up from the bottom left to the top right. Okay, there's not a trick to that. You just have to learn it. Cotangent is going to be a little bit different. It kind of goes back the other direction. We'll look at that later though. Okay, to finalize our tangent graph, we're simply going to take our asymptotes that we've drawn. We're going to take our points that we've shifted the vertical shift up to, and we're going to draw our tangent graph. Now, like I said before, memorizing the way the tangent graph goes versus the cotangent graph is really just that. You really have to learn it by memorization. And so for tangent, it starts down at the bottom left, and I'm going to attempt to do this with the mouse again, although this is very difficult to draw a smooth curve with the mouse. But it starts down here, it'll come up, and it'll come through the point, and it'll come up like this. And it'll just basically repeat that kind of graph all the way down in its entire period. And remember, we said tangent really doesn't have an amplitude because it continues up and down forever. But this is basically how you would draw the tangent of x over 2 plus 2.